we learned that the phrase rate of change is synonymous with the word slope. This is also something you would have learned like back in Algebra 1. You probably leaned into the fact that it was called slope back then. But rate of change, how quickly something's changing, is also what we're looking at here. So a positive rate of change would indicate that the function itself has a positive slope. We're going to use green for positive slopes today. Positive slopes mean that the function is increasing, because if we're thinking about like a positive line, it's going up, yes? So a positive slope, the function would be increasing. Therefore, a negative slope indicates, a negative rate of change indicates that a function has a negative slope. We're going to use pink for decreasing. We used these same colors last time. Negative slope. In AP Pre-Calculus, we are unable to determine the rate of change of a function at an exact point along a graph. You'll need actual calculus for that, not pre-calculus, and we're not getting into derivatives in this course. But what we will do in this class is we need to make sure that we can determine the rate of change at a given point if it's just going to be positive, that's the wrong color, positive, negative, or a third option for us is 0. We're going to try to make sure we know how to determine at least that. We won't find a particular number. Again, it's beyond the scope of this course, but we need to make sure we can do that. We will also compare the rates of change at 2 distinct points. Now, especially for this class, it's important to consider rate of change as if it's a roller coaster. So if you think about this little graph, this is our function, and if we're riding it like a little roller coaster, at first here it's pretty easy to see when you're going up, what kind of slope is that? Positive, easy peasy. You're going uphill. It's a positive slope, you're increasing. And I'm going to skip to T3, so not the next little guy, but the one that's going downhill, this guy over here, it's pretty clear that when you're going down, you have that negative rate of change, right? That makes sense. But what's interesting is at the exact instant or point when your little cart gets to the very, very top of the hill, you are changing between going up and down. So we need something to determine that we are changing between being positive and being negative. That is where you're going to have a slope of 0 or a rate of change of 0. Exactly when you're changing from positive to negative. Because if you think about even just numbers, if you switch from positive numbers to negative numbers, you had to cross 0. So that rate of change right when you change instantaneously is 0. So positive, negative, easy. It has to be at either a maximum or a minimum, exactly when it changes from increasing to decreasing to be considered a slope of 0 for this course. So let's see if we can at least compare these sort of slope ideas to each other. In example 1, it says, the figure shows the graph of function f in the xy plane, which by the way, this entire beginning part of this question sounds extra. Like you're like, okay, clearly it's a function and it's on a coordinate grid. And it has to be written that way because in this course, we're going to use something other than an XY plane in the third quarter. Don't worry about it. That's an April problem, okay? But we have to make sure we're talking about a regular square grid because right now that is what we're working with. Haven't introduced the other ones yet. But we have these 3 labeled points, A, B, and C. It wants us to order the rates of change of f at the 3 labeled points from least to greatest. Okay, least to greatest. First thing we need to do is make sure we know just what type of slope they are. So if I'm looking at point A, is this on an uphill, a downhill, or at a turning point? Uphill. So what kind of slope would it have? Positive, negative, or 0? Positive. Because if we were drawing our little like roller coaster cart, our roller coaster cart would kind of go off this direction. How about B? Wherever B is, would that be a positive or a negative slope? Negative. Why? It's going downhill. If we were riding that little cart, our little cart would be headed downwards. And what's happening at C? 0, because we're turning there, yes? We're changing from going down to going up, so we're changing from decreasing to increasing. So our slope has to cross from 0 to go from negative numbers to positive numbers. So if we're labeling this from least to greatest, which one of those numbers is going to be least, A, B, or C? B. Why B?
Because it's going negatively.
Negatively. Very good. So if we go B first, That's because we know B is a negative slope, a negative rate of change. After the negative rate of change, what would be the next largest? C. Because if we're going from negative slopes or from least to greatest, we have to go from negative. We cross 0 on a number line, and therefore our greatest slope would be at A. That's where our positive slope is. So our order from least to greatest would be B to C to A. Now in this class, we're not going to get exact numbers necessarily for the instantaneous rate of change, but we can still compare the ideas of them. B is going to be the lowest rate of change because it's going down. C is going to be the middle one because it's 0. And then A is the largest number because it's a positive number. Now let's make this a little bit more challenging. Example 2 says the figure shows the graph of function g in the xy plane with 4 labeled points. Of the following points, at which is the rate of change the least? Okay, so let's first go through kind of like we highlighted this guy, and let's highlight this one the same way. Point A, would that be increasing or decreasing? Increasing. So I'm going to draw green, and I'm still going to draw that little line as if it's my roller coaster cart going off of it. I think that's important. You know what? I'm going to draw it even larger than that. So I'm going to draw it as if it's like a full line like this. What's happening at B? Increasing or decreasing? Increasing. So I still have a positive slope. And my line would look something like this. Okay, how about C? Is it at the very part where it turns from increasing to decreasing? It's on the decreasing part already. Okay, so we're going to skip having a 0 here, and we're just going to go straight to decreasing. So it would look something like this. What about D? Still decreasing. Okay, true. And so if I draw my line, it's going to look something like this. We should be able to eliminate 2 answer choices pretty quick. Remember, this question wanted us to find the least. Which 2 of these are for sure not going to be the least? A and B. Why are A and B for sure not going to be the least? They're increasing, they're positive. If we have negative numbers, we know that's going to be smaller no matter what. So the question becomes, if C and D are both negative, how do we know which one is smaller? And here's what we think about. These lines that I drew on here, if we were actually calculating the slope, which one would you say is a steeper negative slope? D is like, it's going down real fast, right? So this is down, but this is real down. If the number is real down, that means it's a smaller slope, a larger negative number, right? The number itself is larger, but if it's negative, it's smaller. In which case, that means D is actually going to be the least rate of change here. Now, because we need to make sure these are our notes and they make sense for us, let's explain our answer to ourselves. We're going to say to ourselves, C and D are both negative. We know this. But D is steeper, which means more negative. Weird concept, but it's more negative because it's going down faster. It's got a steeper slope, steeper negative slope, which means if we were able to find the exact number, which we won't because that's a calculus thing, that number would be a smaller fraction, a smaller number on a number line. So our first concept here in this class when it comes to rate of change, again, is to be able to determine what type of rate of change it would be. And I said we're not going to be able to find the exact rate of change for an instantaneous moment. However, if you flip this over, we are going to be able to find what's called the average rate of change. The average rate of change doesn't find the rate of change at an instantaneous point. That's called the instantaneous rate of change. But this average rate of change, which is a huge concept for this class, like you're going to get tired of me asking you about the average rate of change by the time the end of this class rolls around. But this rate of change is super important. The average rate of change, or I'm going to shorten it to AROC because that's a lot of words to write. AROC, AROC. The average rate of change between any 2 points, not 1 point, 2 points on a graph of f of x is the slope, and this doesn't fit on this line, slope of the secant line through those points. Now, what does that mean, a secant line? Great question. Thank you so much for asking. You take 2 dots and you connect them. That's a secant line. 1 dot drawing a line like we did on the front is called a tangent line. 2 dots draw a line between them. It's called a secant line. Now, the formula for finding the average rate of change is as follows, and this is the formula that will haunt you in your dreams. The average rate of change is f of x2 minus f of x1 over x2 minus x1. This would be a formula I recommend writing on a Post-it note, sticking on your mirror, and reading every time you brush your teeth from now until May. We're going to need to know it. It looks really fancy. But if I change the numerator in this fraction to something that's maybe more bite-sized for you, does this look familiar? What formula is that I just wrote right here? It's like back from Algebra 1, right? It's the slope of a line formula. The average rate of change is the slope, but we're making it fancy and we're using function notation to talk about the average rate of change. Because in this class, we're going to talk about more than one function at a time, so I need to know if we're talking about function f or function g. So we're going to add in and change it to this type of slope of a line. But that's the exact same. Take whatever highlighter color you want right now, and I want you to put like a little cloud around this formula. This is how important it is I need us to like really make this thing stand out. That the formula for average rate of change is f of x2 minus f of x1 over x2 minus x1, which really means outputs over inputs. You guys did this for me on the first day of school. Remember when I had y'all stand at the whiteboards and do those slope problems? That's what we're doing. It's just called average rate of change. So let's see what an example might look like. In this class, the questions that are going to ask you to find slope may look something like this. It says, find the average rate of change for the following functions on the given intervals. What this question has given you is the name of the function g and the function itself, the equation, as well as the interval. So this is the start and this is the stop of my 2 points for my secant line. What I need to do is find out the value of the function at each of these points so that I can plug it in. So what I'm going to do is I'm going to take the x1 and the x2 from this problem, and I'm going to plug them into the function. So just as like sidebar work, I'm going to plug in x1. And what is the value of x1? -2. Yeah, we just labeled it. Which means g of -2 tells me to plug in the number -2 everywhere there was an x just a second ago. Which means I'm going to write negative parentheses -2 cubed plus 3 times -2. Now you grab calculators today. I'm going to let your brains get a break here at the beginning of school, but eventually you are going to have to be able to do these things without a calculator. Majority of this course does not have one, but since we are working on calculator skills today, let's make sure we know how to type this in. So grab your calculator right now. You're going to press negative parentheses -2, not the minus button, the negative. To get the cubed, you press the little up caret button or the shortcut for exponents that you know. Get out of exponent world. Plus 3 parentheses, -2 again. What do y'all get when you type that in? We should get 2. Let's do the same thing. Again, practicing. It feels silly to just sit here and practice calculators, but I know it's either been a whole summer or a couple years since you've touched these calculators, and that's okay. We're going to do the same thing for x2, which means we're going to go back to the original equation, and we're still going to plug in the same number. Well, sorry, it's not the same number anymore. We're going to plug in the number from the other part of this interval, the other x value that I care about for this problem. So in your calculator, -1 cubed plus 3 times -1. Yes, -2. Okay, cool. So we have the two outputs. Now we've kind of lost the plot of what this question was asking. Remember, it's asking me to find the rate of change, so I'm wanting to use that formula. When you're doing the rate of change for me, every single time you compute the rate of change, I need to see the formula written, which means what I'd like to see on this problem is you write the average rate of change is equal to g of x2, which is -1, minus g of x1, which is -2, over those two x values subtracted from each other. So let's talk about what I just did here. I took the formula from the purple cloud on my notes, and I did change the letters. Why do you think I changed the letter from F to G? Yeah, the name of this function is G. Please call the function by its name. So as a peek ahead, what will we be using in letter B? H. Call the function by its name. Okay, cool. So we substituted in then the two values from the interval. x2 where the x2 goes, x1 where the x1 goes. And here's what's nice. You already computed what g of -1 is. Based on what you wrote up here, what is g of -1? -2. And what is g of -2? 2. So our numerator should say -2 minus 2. And our denominator, I know I made it real ugly here with this minus and minus. What happens when you subtract a negative? You add them. So this is really just -1 plus 2. Let's compute this. What is -2 minus 2? -4. What is -1 plus 2? 1. Which means our average rate of change, the slope of the secant line between these 2 points at -2 and -1 is -4. We've just computed the slope. Can we try one more together before I let you try one on your own? Okay, this function is named h. It's a different function, but we're not going to treat it any differently. And it's a different interval, but we're not going to treat it any differently. This is always our x1 and this is our x2. And we want to find the average rate of change, or the slope of the secant line between these two intervals, between these two x values on this function. So what I'm going to do is I'm going to take them separately and evaluate. I want to first do h of 1, which means everywhere in this fraction that there was an x, I'm going to put a 1. This one's pretty easy to do in your head. What's 1 plus 1? 2. What's 6 plus 1? 7. We leave it as a fraction. We're also going to compute h of 4. So everywhere there was an x a second ago, you're going to plug in a 4. 4 plus 1 is 5. 4 plus 6 is 10. Oop, 5 over 10, that reduces. What does that fraction reduce to? 1/2. And now we have our two output values to be able to plug into our average rate of change function. Since we are computing the average rate of change, again, we're using the function notation version of this equation, and we always at least write down the name of the function to show our work, which means this becomes h of 4 minus h of 1 all over 4 minus 1. Well, let's substitute in what we know. And we are going to put fractions in our fractions. Don't worry. Maybe worry, but don't worry too much. h of 4, what did we get as the evaluated version of h of 4? h of 4? 1/2. And we're going to subtract h of 1, which is 2 over 7. And then we're going to subtract 4 minus 1, which I can't help myself. 4 minus 1 is 3. Now, eventually we will get into how to do this by hand, because I know that we need to review fraction skills, but you do have a calculator in your hand today, and since we're also practicing calculator skills, let's go over how to type this in case you don't know, because there is a super shortcut on these nice new calculators for that fancy fraction, and I know a lot of people don't know it, so let's watch. I've pulled my calculator up on the screen. Can you see it? She's on. Okay. When we're typing this in our calculator, we want to do a fancy fraction. Do y'all remember the fancy fraction? Does anyone remember how to get it? There's an even shorter shortcut than alpha y equals on these calculators. Do you see over this button that says xt theta n, there's like a box over box? Doesn't that look like a fraction? What color is it? Press the green button alpha and then press that button oh, wrong direction. The fraction bar should show up. Now, in our large fraction bar for average rate of change, we then have another fraction in the numerator. So I'm going to press alpha and that button one more time, and it's going to put a fraction in my fraction. What? That's 1/2. And I'm going to subtract another fraction. So I press alpha xt theta n again. This is 2/7, and I'm going to divide by 3. Did everybody find those buttons? When we press enter, what do we get as our average rate of change? 1/14. Fabulous. So we get 1/14 as our average rate of change for this interval on the function h. So we've seen how we calculate the individual number for the average rate of change. But let's go back to comparing some rates of changes. Now on the front we were doing instantaneous rate of change comparisons, and on the back here we're gonna compare some average rates of changes. So in these average rates of change, we have multiple intervals for each of these answer choices, and we have a graph that represents the function itself. So we're not going to be plugging necessarily in numbers, because we're going to be able to estimate the average rate of change from this graph. So what I want to do here is, and this doesn't follow my color scheme, but just to make it make sense for you on your notes, we're going to color A pink, B blue, C green, and D purple. Again, not that it follows the green means up, red, pink means decreasing color scheme. But let's find the slope of each of these secant lines on this graph. The two intervals are the x values where this particular secant line is going to start and stop. Meaning for A, I'm going to put a dot at 2, and then I'm going to put my next dot at 3. Here's a question I expect to have. Ms. Quigley, you put those both dots at 6. So what do I mean by put a dot at 2 and put a dot at 3? X value. The x value 2 and the x value 3. Wherever the graph exists, when the x value is 2 and the x value is 3. Now you're going to play connect the dots, because secant line means that you're going to draw a line in between them. That is the secant line between them. Let's do the same thing for B. B says to make a secant line between 3, boom, and 5, boom. Do we see the dots at 3 and 5? I'm coloring this one blue personally, but what we're going to do is make a secant line. Basically, play connect the dots. Draw a line between them. That's a secant line. Let's draw our secant line between answer choice C, which is 5 and 7. So we have a dot at 5, and we have a dot at 7. We draw a secant line between them, which again sounds like I'm saying play connect the dots, because essentially I am. Connect the two dots, that's a secant line. Our last answer choice here says to go from x value of 7 to an x value of 8, and draw your secant line. So the question, once we have all of these secant lines drawn, the question that this particular example is asking is for which of these intervals is the average rate of change the greatest? Another way it could have asked this question is which interval has a secant line with the largest slope? Well, let's think about it. Which one of these colors has the largest number representing its slope? Pink, blue, green, or purple? What kind of slope would the pink one be? 0. What kind of slope would the blue one be? What kind of slope would the green one be? How about the purple? So which one's going to have to be the greatest? The green one. Because the green one has a slope of its secant line between those 2 points that is the only positive one, first of all, but it's also the largest positive number, the most steepest, what? That's not correct English. The steepest positive slope, it would be the greatest. So we're comparing the slopes of those secant lines. Similar to how we compared the slopes of the instantaneous rates at the front, but this time we can draw secant lines between them. The last way that this particular topic is going to potentially ask you questions about the average rate of change is giving you a table. So if we think so far what's happened is I've given you an equation, I've given you a graph, and now I've given you a table. All of these multiple representations, we can find the average rate of change for the different values. This question says, the table gives the life expectancy of U.S. females born in a given year over successive 50-year intervals. Over which of the following intervals is the average rate of change in life expectancy the greatest? So we need to find or calculate the average rate of change for each of these values. Here's what I expect to see for each of these. You can't see everything all at the same time. For answer choice A, we'll do it together, and then I'm going to have you practice B, C, and D on your own to find the number. But what I'm looking for here is the average rate of change in the function called L. Where did I get the L from? Right here. Name of this function is L. Between 1800 and 1850. So I'm going to do the output at 1850 minus L of 1800 over 1850 minus 1800. Let's discuss how I wrote that down. This is just the formula from the cloud at the top of your page with the name of the function, which is capital L, and the two values here, x2, x1. Now here's why tables are great, because you don't have to calculate anything like we did on example 3, because the table shows you everything. If the input is, 1850, what's the output? 46.1. So we're going to put 46.1 in that top portion. What is the output when the input is 1800? 41.24. And just because I can't help myself, what's 1850 minus 1800? 50. So that denominator becomes 50. This is where you would turn to your calculator and you ask your calculator, hey man, what is 46.0 minus 41.24, and then divide that by 50, or make one giant fraction. I'm going to fast forward through that because at this point you've shown me you can do the fancy fraction. You would get 0.0972. What an aggressive number of decimals, Miss Quigley. You're correct. You're always going to round to 4 decimals in my class. How many decimals? From here until May. How many decimals? Okay, 4. Always 4. Here's what I would like for you to do. I want you to try to get me the average rate of change for answer choice B, C, and D. Because then we can answer the question. The question is, which has the average rate of change that's the greatest? So you're basically just trying to figure out which of these has the greatest number when we compute the rate of change. You can work with the people around you. Make sure you and they know how to type these in the calculator and write the correct function. I'll give you some time to work. Okay, if you haven't quite gotten through, hopefully you got through at least a few of them. I've done my work, shown my work for B, C, and D, but I didn't get the final answer up there yet. If we do actually compute these for answer choice B, we should have gotten 0.1506. For C, 0.3404. And for D, 0.2236. If I went faster than you, you'll have time to catch up. Don't worry, don't stress. But if these are the average rates of change that we find for each of these intervals of years, the question again, remember, is which interval is the average rate of change in life expectancy the greatest? Greatest? I just said greatest. Greatest. Which one of those numbers is greatest? A, B, C, or D? C. C is the correct answer. This makes sense to us if we actually think about this in real life. If this is life expectancy of U.S. females born between 1900 and 1950, let's just think about like electricity and sanitation that was improved between 1900 and 1950. Most likely that's going to be correct. So math can go into sociology and history, all that good stuff. Data, love it. Questions, comments, or concerns before we call it for today? Okay.